Elon Musk just made a shocking announcement at the latest SpaceX event. Tesla's humanoid robot, Optimus, is going to Mars. Yeah, you heard that right. The 2026 mission to the Red Planet will include multiple Optimus units on board, with the goal of preparing Mars for human colonization. This isn't some far-fetched science fiction dream anymore. It's happening. It's real. And it's coming faster than most people expected. Welcome back, friends. Alfie here with a major update in the world of robotics and space exploration. Elon Musk has officially announced that Tesla's humanoid robot, Optimus, will be heading to Mars as part of SpaceX's 2026 mission. It's a bold move aimed at preparing the Red Planet for future human habitation. You're watching the AI Nexus, and today, we're breaking down every detail of this extraordinary plan. Let's go. Here's the quote that's got everyone talking.
So the first flights there we'll send with the Optimus robot, so we can go out there and explore and kind of prepare the way for humans. And that'll be a very cool image if we're able to achieve it by launching end of next year. It would actually technically arrive in 2027, but that would be an epic picture to see Optimus walking around on the surface of Mars.
Musk said, "The first flights there we will send with the Optimus robot so it can go out there to explore and kind of prepare the way for humans. By launching end of next year, we'll actually technically arrive in 2027. That's the timeline. Launch in late 2026. Arrival in 2027. Optimus becomes the first humanoid explorer on Mars." So today, let's unpack everything about this mission. The why, the how, and what it really means for the future of humans living on Mars. This latest update came as part of a broader SpaceX event centered on the mission to make life multi-planetary. Musk has never shied away from bold predictions, but this one feels like a serious turning point. The combination of SpaceX's rapidly advancing Starship program and Tesla's progress with Optimus means that we're moving from ambitious blueprints to practical execution. And the key to unlocking Mars? It's not astronauts, at least not yet. It's robots. The decision to send Optimus to Mars ahead of humans isn't just symbolic, it's strategic. Mars is hostile, unpredictable, and, quite frankly, dangerous. Before we send any humans, we need to understand what we're dealing with. That's where Optimus comes in. These robots will essentially serve as our eyes, hands, and feet on the surface, working autonomously to gather data, perform essential tasks, and simulate the conditions humans will one day face. This is the clearest sign yet that Musk sees Optimus as much more than a factory assistant or warehouse operator. He's positioning it as the first interplanetary worker, a robotic frontrunner capable of performing the hard, dangerous, and repetitive tasks that need to be handled before human boots ever touch Martian soil. There's a lot to unpack here, starting with what Optimus is actually expected to do once it lands. Musk didn't go into minute-by-minute mission details, but based on Tesla's development track and SpaceX's needs, it's easy to imagine a set of high-priority goals. These robots are likely to explore the terrain around the landing site, scouting for stable ground and suitable areas for building future habitats. They'll probably test soil composition and environmental conditions to figure out what kind of shelters we need. And given Optimus's rapidly developing dexterity and mobility, it wouldn't be surprising to see them assembling prefabricated structures, setting up solar panels, or testing tools that humans will eventually rely on. Over the last year, we've seen Tesla roll out impressive updates on Optimus. This isn't the slow, tethered robot of 2 years ago. The new versions walk untethered, pick up objects with precision, sort items on the fly, and maintain balance in real time. The most recent demos show Optimus sorting battery cells and performing tasks with fluid, human-like movement, all powered by Tesla's own end-to-end neural networks. These are not just gimmicks. They're signs of a robot that's getting closer to operating independently in unfamiliar, uncontrolled environments. That's a big deal when you consider what Mars throws at you. The terrain is unpredictable. Temperatures can swing wildly. Dust storms can last weeks. And worst of all, the communication delay between Earth and Mars means there's no real-time control. Whatever we send to Mars needs to think for itself. It needs to respond to problems on its own. And that's why Tesla's full-stack AI development is so critical here. Optimus can't just be a robot that waits for instructions. It has to be smart, adaptive, and fully autonomous. SpaceX isn't taking a one-size-fits-all approach either. While Starship is designed for massive cargo capacity, it also allows for flexibility. Musk hinted that the 2026 mission could include multiple Optimus units, possibly with variations specialized for different tasks. One could focus on environmental sensing, another on lifting and moving equipment, and another on systems testing. All of them would be essential in rehearsing the logistics of future human missions. This kind of modular robotic workforce isn't just futuristic, it's necessary. Humans need breathable air, stable temperatures, radiation shielding, and emergency systems. Robots don't. That gives them an edge when it comes to setting up the first phase of a Martian outpost. They can operate in extreme cold, take solar energy straight to battery, and work non-stop without breaks, sleep, or psychological stress. It's efficiency multiplied. What's even more exciting is that this mission is a fusion of Tesla's AI expertise and SpaceX's hardware. Tesla brings the brains, advanced neural networks trained on real-world perception and manipulation. SpaceX brings the brawn, the massive rocket infrastructure needed to transport heavy machinery through deep space. For the first time, we're seeing these two Musk-led companies operate not just in parallel, but in unison. The AI is going to Mars, and the rockets are making it happen. Now, about the timeline. A late 2026 launch puts the arrival date in early 2027, which aligns perfectly with one of the optimal Earth-Mars transfer windows. These windows occur roughly every 26 months when Mars is closest to Earth. That's when SpaceX can send the most payload for the least amount of fuel. It's not just efficient, it's necessary for missions of this scale. But make no mistake, the clock is ticking. Starship has to be fully operational, safe, and proven for long-haul cargo delivery by then. That's ambitious. But SpaceX has been making real progress with each Starship test flight, including better heat shielding, mid-air relights, and even soft landings. If those milestones continue at this pace, we could absolutely see an uncrewed, Optimus-filled Starship lifting off in 2026. Let's talk about what this means in the bigger picture. For the longest time, Mars colonization has lived in the world of someday. Someday we'll have the tech. Someday we'll send people. Someday we'll build habitats. This mission shifts that conversation to now. We're not dreaming about it anymore. We're preparing, actively, with real machines. When Optimus sets foot, or rather robotic foot, on Martian soil, it becomes the first humanoid to explore another planet. That's a historical moment on its own. But more than that, it's a practical testbed for every system we'll eventually rely on to support human life there. The data we collect from these robots will inform everything, from the design of future habitats to the placement of life support systems to the schedule of future crewed missions. And let's not forget what this represents for the robotics industry. If Tesla can demonstrate that its robots can function independently on another planet, it sends a signal to every other company in the space. Step up or fall behind. We're entering a new era of robotics. Not just assistants in the workplace, but pioneers in space. The market for space-rated robotics will explode. Companies will race to build robots optimized for zero-gravity construction, extraterrestrial farming, off-world repair. A new industry is being born, and Tesla just claimed the first flag. That has ripple effects back here on Earth, too. Everything we learn from Mars has potential applications at home. Power efficiency, remote operations, durability in extreme environments. All of that feeds back into better robots for Earth-based use. So even if you never plan to leave the planet, you'll benefit from what Optimus learns on Mars. There's also a cultural shift happening. This mission turns robots from curiosities into frontline explorers. When the world sees Optimus walking on Mars, People will start to imagine new futures. Kids will grow up dreaming not just of becoming astronauts, but of building the robots that go before them. Students in robotics, AI, aerospace, they'll see real opportunities in what was once considered science fiction. This mission will be a spark. Musk's broader vision is crystal clear. If we want to survive as a species, we need to become multi-planetary. Earth is beautiful but fragile. One asteroid, one supervolcano, one global conflict, and everything changes. Having a self-sustaining population on another planet isn't just cool, it's insurance for humanity. And now we have the tools to start building it. Optimus is the key that unlocks the door. It allows us to explore safely, prepare smartly, and expand sustainably. It's the logical first step in an interplanetary relay where robots run the opening lap, setting up the course for human explorers who will follow. So the next time you see an Optimus prototype lifting a box in a Tesla factory, just remember, within 2 years, that same robot may be walking on Mars, preparing the way for a human civilization in a place no human has ever stood. And that, more than anything else, shows just how fast the future is coming. Big companies are making bold moves, but it's often the underdogs who redefine the game. Enter Kscale Labs, a tiny team with a massive vision, an $8,000 humanoid robot that's already got the attention of OpenAI and NVIDIA. Let's get one thing clear. This isn't some toy or concept model that will collect dust on a shelf. We're talking about a 5-foot-tall humanoid robot that walks, learns, and interacts, designed to live right alongside us in real-world environments. And it's not just functional. It's adorable, compact, and accessible in a way we haven't seen before in the humanoid space. OpenAI and NVIDIA have already taken notice. That alone tells you this isn't your average DIY robotics project. This is a serious, scalable technology that could democratize robotics in ways we've only dreamed of until now. Kscale Labs posted on Twitter, "In 5 months, we built an open-source humanoid stack, an affordable 5-foot humanoid RL-VLA models, and an OS for our Sim2Real pipeline. For anyone to build on. We're releasing our robot learning and Sim2Real stack this weekend for you to try. Stay tuned." Let's unpack what that actually means. First of all, building a humanoid robot is hard. It requires a mix of mechanical engineering, software design, control systems, artificial intelligence, and a lot of money. Big players like Tesla, Figure, and Boston Dynamics are pouring tens of millions into their humanoid platforms. And here comes Kscale Labs, a tiny team, building something open source and surprisingly capable in just 5 months. And for $8,000? That's unheard of. That's a laptop budget. Most humanoid robots today are priced like exotic cars or small homes. Tesla's Optimus is still in development and expected to cost much more. Boston Dynamics Atlas? Custom-built and not even available for commercial use. Sanctuary AI, Apptronic, Agility Robotics. All are building high-end systems meant for enterprise-level deployments. But Kscale Labs isn't building for Fortune 500 companies. They're building for everyone else. Makers, developers, schools, researchers, hobbyists, small businesses. Anyone with an idea and a passion for robotics can now get their hands on a real humanoid platform for a fraction of the usual cost. And it's not just the price that's radical. It's the openness. Everything Kscale Labs has developed is being released to the public. That includes their robot learning stack, reinforcement learning, RL models, vision language action, VLA models, and their simulation to reality, Sim2Real operating system. If you're in AI, robotics, or even just tech curious, this is huge. What they've done is create a full-stack framework for building, training, and deploying humanoid behaviors. That means you can prototype tasks in simulation, train your models virtually, and then transfer those models directly to a physical robot that costs less than an iPhone Pro Max. That's not just disruptive, it's paradigm shifting. Now think about what happens when developers around the world start hacking, customizing, and improving on this platform. We're about to see an explosion of innovation in humanoid robotics. driven not by corporations, but by communities. OpenAI and NVIDIA aren't watching this because it's cute. They're watching because this could accelerate robotics development globally. And that's where things get really interesting. Because historically, progress in humanoid robotics has been bottlenecked by cost and complexity. You need deep pockets to even begin experimenting. Most universities can't afford to put a humanoid robot in every lab. Most AI startups can't afford the hardware. Most developers don't even get to touch these machines unless they're at a well-funded institution or company. Kscale Labs just blew that door wide open. Now anyone can experiment with real-world locomotion, manipulation, task planning, and human-robot interaction. Anyone can build a custom humanoid assistant. Anyone can explore the frontier of embodied AI. Let's also talk about the design of the robot itself. It's small, just 5 feet tall, and that's by design. It's meant to coexist with us in homes, schools, and workspaces. Unlike some industrial bots that look intimidating or out of place, this robot has a friendly, approachable aesthetic. Think less Terminator, more WALLE, and its size makes it incredibly versatile. It's easy to store, transport, and maintain. It doesn't need specialized facilities or oversized doors. It can roll right into your apartment or lab. That means humanoid robotics just became a household conversation. This robot could be your new lab assistant, your code testing buddy, your STEM classroom partner, your home automation experiment. And it's not just physically capable. It's smart. Kscale Labs' integration of RL and VLA models means this robot doesn't just follow hard-coded instructions. It learns, it adapts, it interprets human cues, sees the environment, and makes decisions based on multimodal data. That's exactly the kind of intelligence that companies like OpenAI are investing in. So it's no surprise that this project has already grabbed their attention. Kscale Labs is essentially building a sandbox for embodied intelligence. And that's the holy grail of the next AI wave. The Sim 2 Real OS is also a major leap forward. Traditionally, training robots in simulation is fast and safe, but transferring that learning to real-world hardware is riddled with problems. Sensors don't behave the same. Physics engines aren't perfect. Reality is messy. But Kscale's OS bridges that gap. They've designed their system so that what works in simulation translates reliably to the physical robot. That means faster iteration, better training, and more robust performance. And they're giving it away. That's the part that still stuns people. This isn't a stealth mode project looking to raise $1 billion round. This is a passion-driven mission to open up humanoid robotics to the world. It's the classic Silicon Valley garage story, reborn for the AI age. So where does this go from here? The impact could be massive. Open source communities move fast. Within weeks of release, we could see upgraded models, new task libraries, custom hardware mods, third-party integrations, and entirely new use cases. Schools could begin training the next generation of roboticists using real humanoids. Small startups could build entire businesses around custom applications. And maybe most importantly, this pushes the conversation about robots living among us forward in a big way. Until now, humanoid robots were mostly aspirational. We imagined them in science fiction or watched them perform choreographed demos on stage. Kscale Labs is changing that. They're making humanoid robots feel personal, practical, and present. So what do OpenAI and NVIDIA actually see here? For OpenAI, this is about testing embodied intelligence in the wild. Their language models are powerful, but pairing them with a robot that moves and acts adds an entirely new dimension. Imagine fine-tuning GPT-like models in real time with a robot learning to fold laundry or fetch a cup of coffee. For NVIDIA, this is a hardware playground. Their GPUs power most of the AI and simulation engines in robotics today. A widely adopted, low-cost humanoid platform means more demand for their edge computing systems, their developer tools, their AI accelerators. In short, this is a win-win for everyone. And let's not forget the timeline. Kscale Labs built all this in just 5 months. That speaks volumes about what a small, dedicated team can do when they're laser-focused on solving the right problem. No big bureaucracy, no corporate bloat, just builders building. It also sets a new bar for everyone else. Now that a sub-10,000 humanoid exists, every other robotics company has to rethink its roadmap. If you're charging six figures, you'd better offer something truly next level. Because developers now have an alternative that costs less than a gaming rig. To sum it up, Kscale Labs has just democratized humanoid robotics. Their $8,000 open-source robot isn't just a tech milestone. It's an invitation to experiment, to learn, to innovate, and to help shape the future of AI and robotics in real physical spaces. It's open, it's affordable, it's adorable, and it's already turning heads at the highest levels of tech. So if you've ever dreamed of building your own robot, now's the time. The tools are here, the platform is live, and the future of humanoids just got a whole lot closer. Stay tuned, because Kscale Labs just changed the game.